Thank you, Magnus. It's so nice to see that there are events in person again, and thanks for the invitation. So let me share my screen. All right, so thanks for the invitation again, and hi everyone. My name is Omar from Hugging Face. Today I'm going to talk about how to build ML in an open and collaborative way. The title might be a bit not super clear. I will talk a bit about how to share models, how to create demos, how to collaborate and work with other people, and some open science and open source initiatives. So very briefly, quickly about me, I'm originally from Peru. I moved to Switzerland a couple of years ago to work at Google, and I've been working at Hugging Face for quite some time now. I focus in the open source team as an ML engineer. I work building open source collaborations, creating connections with communities in other libraries apart from the core NLP libraries from transformers. We also have collaborations with libraries in other domains, such as stable baselines in reinforcement learning or SPACY or speech brain in the auto domain. So that's what I do, but let's jump directly to the talk. And as probably most of you already know, Attention is All You Need is a paper that came almost 5 years ago, 4 years and a half ago, which pretty much kickstarted a huge revolution in the NLP domain. After that paper came out, Attention is All You Need, there was a Cambrian explosion of a bunch of different transformer-based architectures. So GPT is a very famous one, then it was BERT, then there are like many BERT-based models, so Roberta, for example, Albert. And yeah, this is actually already outdated. We did this image around about 6 months ago, and it's already quite outdated. There are a lot of new, very interesting transformer-based architectures. And pretty much the huge revolution of this field was applying transfer learning to NLP. So as probably most of you already know, in the traditional supervised learning approach, if you want to train a model in different domains, you will train one model for domain A and another model for domain B, or a model for task A, a model for task B. And what transfer learning allows you is to train a very large, powerful model, and then leverage everything that this model learned for new tasks or new domains. So it's quite interesting. Probably you've already seen this in computer vision. Pretty much how it works, for example, with convolutional neural networks is that you will have some layers that are like the feature learning layers, and then you will have some classification head. And these feature learning layers will learn what features are important in an image. And then what you can do is just change the classification layers depending on the specific task. So if your goal is to classify dog versus cats, you will have a certain size for your classification head. But if you want to classify ImageNet and its 1,000 classes, you will need a different head. But you can always leverage like the same feature learning layers. So the concept is pretty much the same for NLP with some differences, of course, but the idea is that you can train a large base model, which will require a lot of compute cost, a lot of data, days of training, and that most likely just certain universities or research labs like Google or Microsoft will be able to train these models. But what is very cool is that if you open source these models, if you make these models available for everyone, what can happen then is that you can use transfer learning through a process called fine-tuning. And this pre-trained language model, which was trained by these large companies or research labs, they have like certain statistical understanding or knowledge of a certain language or domain. So for example, you might train a model for Swedish, right? And this model will already have like this statistical understanding of the language. And then you can use this large model with fine-tuning, and just with some hours of training with a small data set, you can do fine-tuning for a certain task. So for example, if you want to do text classification in Swedish, you can use this large BERT model and use it for your own task. We'll dive a bit more into this in a couple of minutes. But what is quite interesting is that until about a year and a half ago, this was only for text, for natural language processing. But nowadays, this is also started to be used in other domains. So for example, there are multimodal models. DALL-E is a very interesting one from OpenAI. And the idea is that you have a text prompt, and then the image is completely generated by the model. And this is clearly like data that the model never saw. The model never got images of armchairs in the shape of an avocado. And the model is able to generate actually quite interesting results. Or for example, multimodal document search within. So yes, as I was saying, transformers now are everywhere. So in NLP, but also in speech, Facebook has been doing quite a bit of very interesting research with Way2Beg and a lot of new models in the last year. In the vision domain, every few months are like new models for image segmentation, image classification, and now there's also like quite a bit of research in time series and reinforcement learning. So transformers were thought to be only for NLP until not that long ago, and they have been proven to be able to achieve quite interesting results in other domains. All right, so it's quite interesting. It's very cool that we can have like these large models, but then there's a gap between industry and research, right? Or how I, as a, I don't know, as a small company without that many resources, or how I, as a person that wants to train a model for a low resource language, how can I use these models? What can I do? Yeah, and in theory, you should be able to access the code of how to train these models, right? So for example, in Archive, many times you can access the GitHub repository. So if you code a paper, you might find the code, but the issue is that this is not easily reproducible. And not even there are like so many models right now. So there is Per, Elmo, Ernie. Yeah, you can see like this image here at the left, and this is already about 2 years old. And then even if you can find the code, you've probably seen that many times the code that is resulting just from a paper is usually not the highest quality code. So it could be using like very old dependencies, sometimes like Python 2, for example, here. The APIs might be inconsistent, there might not be any documentation, or you might run the same code and you might not get the same results. So there are a lot of reproducibility issues, and that's where Hugging Face tried to help. So a couple of years ago, Hugging Face was created with the goal, well, it pivoted a bit, but the main goal was to democratize good machine learning. And this comes with the idea of making machine learning accessible to everyone, making things open and open source. So the idea is that everyone can have the ability to contribute to the greater goal of solving NLP or machine learning. And this means that if we want machine learning to be accessible to everyone, that also means that people with not that many computational resources should be able to leverage all of this work. So how do we plan to do that? Machine learning should be easy to access. So if you want to try out a model, you can do it very easily. And we have created different open source libraries, and we try to do open science and research. And we've created different libraries such as transformers or datasets, which are like two very famous open source libraries, which are in GitHub. They have over 1,000 contributors and over 50,000 stars in the case of transformers. But we also have the Hub, and the Hub is a central place in which you can find models. Originally, it was just for transformers and not only for NLP, but nowadays you can find models from Alien NLP, from Flare. You can find vision frameworks such as TIM, if you know it, and then for speech, such as PyNode or ESP.NET and others. This screenshot is extremely out of date. It says 14,000 models. This was about 6 months ago. Now we have 30,000 models. We have 29,600 models. So if you want to submit some models in the next couple of days, you might have the 30,000th model. And yeah, it's great because it really enables reproducibility. The models that you find here are repositories. So these are like Git-based repositories. So if you've used GitHub before, it's like very similar in the sense that you can go here, you can find the weights, and maybe it will be a bit clearer once I show you like one repository. So let me just jump directly into a very large Swedish case. And what you can see here in one repository is that at the top you have a couple of tags that help with discoverability. Let me zoom a bit. So for example, you can see that this model is in PyTorch with the transformers library. You can see here like the language is Swedish. And if you click it, you will see all of the Swedish models that are enabled on the hub. What you see here in the middle is something that we call the model card. The model card was a concept proposed by Meg Mitchell, a researcher back then in Google, nowadays at Hugging Face. And it's an extremely important artifact that documents what a model is. And it has sections such as the model description with the hyperparameters. It has a description of what was the data used to train the model. And it also has like a section with intended uses and limitations, because one core issue with transfer learning is that if the original large model has some biases, and then you apply transfer learning, the models that were fine-tuned on this original model will likely also transfer these biases. And also, like here at the right, you can see like this use in transformers link, which will give you a snippet that will allow you to just copy paste this in a Colab and try out the model like in a couple of minutes. So I was talking about Git-based repositories. What's that? So you can go to files and versions, and that's the nice thing about this being open source, is that you can here access like the weights of the model, but you can also see things such as the vocabulary, information about the tokenizer. You can go to the config file. So the config file has things such as the hyperparameters. You can go to history. So with Git, the nice thing is that everything has version control, and you get like different commits. So if you use GitHub before, the usual workflow is that you do like git add, git commit, git push, right? And when you do git push, that's uploaded to the platform. It's the same here, and every commit here is a different point in the version, like a different version of the repository. So it's quite useful because this repository can be accessed by many people. So if you're working in a team, it can go from a school project to a company of thousands of people. You can use these repositories to have many people contributing to a model. And you can have things such as branches, you can have tags, you can have different people working at the same time. So this only has one branch. And you can do, here at the bottom, you can see like you can do just git clone, and you will clone this repository locally. So yeah, it's quite powerful. And then at the right, you can do things such as filtering depending on which is the task of your interest. So as I was telling you before, originally we only had like NLP. Nowadays, we also have a couple thousands models for other domains such as audio and computer vision. So for example, if I go to image classification, there is a model called Vision Transformer by Google. And here at the right, by the way, I forgot to mention this, you can try out the model directly in the browser. So for example, here, okay, I don't speak Swedish, so I won't be able to try it out, but you can just click here, hello, and it will run an inference that you can try out. Yeah, and again, this works for different domains. So for example, also like for speech-related things, you can use models such as Facebook Fast Speech 2. And given a text, for example, it will generate an audio file that will create synthetic audio. And although originally it was only for transformers, nowadays we have integrations with libraries such as Keras, PyTorch, Team, Stanza from Stanford, Asteroid, stable baselines for reinforcement learning. And right now, I feel like I'm just throwing you a bunch of different names. These are like open source libraries, and all of our endpoints are open, so anyone can very easily use the Hugging Face. So it's not limited to one domain, or it's not limited to one library. It's really open to anyone that wants to share and collaborate with machine learning. You can also filter depending on the datasets, languages, licenses, and more things. And nowadays we have 20 tasks, 15 libraries, and 180 languages. So it has grown quite a bit in terms of usage and the scope of what we were doing originally. So let me show you a couple of features. I already showed you the first three. Two quick kind of recent features. The first one is TensorBoard hosting. So you probably know TensorBoard, and it's a way in which you can have like this nice visualization of the model when it was being trained, which are just like log files. And what you can do now is if you upload any TensorBoard metrics logs to the hub, you will automatically get like this free hosting embedded TensorBoard directly here. So you can see, for example, I don't know, for example, if the learning rate was changing and what was the impact on the metrics, things like this. Another feature is metric reporting. So this is another model which is to do automatic speech recognition. Automatic speech recognition is a task in which, given an audio, you transcribe and you give a text, right? And similarly here you have the model card. But what is interesting here is that users can also report metrics. So here at the bottom right, you can see, let me zoom again. You can see the word error rate and character error rate, which are two very common metrics for automatic speech recognition in the common voice datasets, which is a very important dataset for automatic speech recognition by the Mozilla Foundation. And what is cool here is that this is self-reported, so it's not necessarily validated, but you can click here. Sorry, I think. Oh yeah, you can click here in View Leaderboard Papers with Code. Ooh, I think this one got changed last week. Right, so I will need to check this. Let me check once again. So you can filter here for models that have these metrics. And you can click in View Leaderboard Papers with Code, and you will get all of the models that were evaluated with this dataset, and then you can compare the metrics. So this allows you to find like the best model for a certain metric for certain datasets, which can be quite powerful. This is a relatively new feature, but we already have a couple of thousands of models and people reporting these metrics. One last thing is CO2 emissions. So something that we've enabled recently is for people to report the CO2 emissions required to train a model. So for example, here you can see that people report like the CO2 emissions are 0.3 kilograms. And we have made tools internally within transformers to report this automatically if that's something that you would like to do. But anyone can really do it. It's like, as you can see, the model card, which is what I was showing you before, it's like this section. It's really just a markdown file under the hood. It's just an empty file, which has some metadata here at the top, which has, for example, the language, tags, and finally, like the CO2 emissions. So it's very interesting, especially with transformers. There has been many concerns about the ecological impact of training like these huge language models. So this allows people to share and have more accountability in terms of which was the ecological impact of training this model. All right, 1 second. Yeah, so as I was telling you before, we have integrations with a couple of other libraries. Sometimes these are integrations within the same library. Sometimes these are third-party integrations. For example, we have like a push to hub Keras that allows people to upload TensorFlow models. And our endpoints are public, so again, like anyone can really use it. All right, so the usual workflow returning to the models is that you can go to the hub, explore the hub and find like a good pre-trained model. You can pick it, and then you can do transfer learning or fine-tuning. So you will train that model with some small changes in the classification head, for example, if it's text classification, and you will be able to do like fine-tuning with a new data set. And once you train it, people usually go to the hub again and they share their work. Why to share their work? It's the same reason. We want to make things accessible, reproducible, And although you might think that your models will not be useful to anyone, you might be surprised by how many people can leverage the work that you've done. So we really try to push everyone to work like in an open fashion. So there was this component before, which was datasets. And the hub, apart from allowing you to host models, also allows you to host datasets. So you can go here. We have, I think, around 3,000 datasets as of now. And similarly, you can filter at the left by language, by size of the dataset, by the license. So for example, Glue is a very famous dataset. Similar to a model card, you have a dataset card that documents the model. And you can even preview certain parts of the dataset. So for example, here you can see which was the label. You can see like different subsets of the dataset. You can go see like the different splits. So this also allows you to briefly explore the dataset. You can even see like which models were trained on this dataset or fine-tuned. And again, this is not limited just to text. For example, common voice, like this very important audio dataset. So we have in the hub over a few thousand datasets available. We have for many hundred languages, and we also have like a Python library called Datasets, which allows you to load any dataset in one line of code. So for example, if I go to Glue, which was the first example I was showing you, you can click here using dataset library, and just with these 2 lines of code, you will be able to access this dataset. One very common issue in engineering with machine learning is that some of these datasets might be huge. So they might be terabytes of data and they might not fit your computer. So we have something called streaming. So streaming pretty much allows you to just load the dataset on the go. So you just load whatever is being used, and then you don't need to load all the dataset at the same time in the computer. And this allows you to train like large ML models or ML models with large datasets. And it also enables like iterating very quickly. All right, so let's say that you pick a model, you pick a dataset, you did the fine tuning, you shared it in the hub. All right, so we are done now. I think that's pretty much everything. But then you realize as a student, a researcher, an engineer in a company, a freelancer, that you don't have like any clear way of showing this or demoing this to other people. So for example, let's go to a very famous model, which is GPT-2. So, all right, so let's say that you have this, but then what can you do with it, right? How can you easily like show this to maybe not even non-technical audience? So something that you might want to do is build a demo. And then you realize that if you want to build like a very nice demo, you might need to learn a bunch of, I don't know, front-end or back-end tools. And usually ML engineers are not very fond of web development. So why do you want to build demos, right? So first, it allows you to easily present to a wide audience. So let's say that you want to present in a conference, if you want to present like a final project or present like non-technical audience, like demos enable this. The second part is that it increases reproducibility of research. Many times the results that you will see in papers are very like handpicked or cherry-picked. And what this open demos that anyone can go and anyone can try and anyone can create, what these demos enable is that anyone can see how the model actually works, right? And finally, it also allows to identify and debug like failure points. Maybe even if you think that your model has no biases at all, probably if other people start to try it out, they will find certain cases in which it's not working. So for example, if you have like I don't know, image labeling, image captioning demo or model, and you just try it with white people, and then you try it with a black person, the results might not work correctly, right? And many times people won't think about these kind of things, and that's why it's very important to make sure that any person can try out and identify and debug failure points. So yeah, so we probably don't want to learn a bunch of web development technologies. So I will talk about 2 different open source libraries. One is called Radio and the other is called Streamlit. So let's say that we want to build a demo such as this. So this is an interactive demo in which you can input a text and it will translate to Spanish. And you can even like take screenshots of this and share it in social media. Yeah, it sounds a bit scary, but the code is actually quite easy. It's only like these 15 lines of code. So I'm going to use transformers, but these demos can be built with any library. So they can be done with transformers, TensorFlow, Spacey, whichever library you want to use. And the important part in Gradio is this interface here at the bottom. And it has three main components. You have the inputs, which in this case is just a text box. You have an output, which is the text. And then you have an inference function, which is this predict function. And this predict function will take an input and an output. So in this case, given an input, given any text, it will use a high-level function in transformers, which is called pipeline, to make a translation and then return. You can try it directly in Colab, and maybe we can even like go directly to it. So we can go to Colab, and I will share a list in the Zoom chat. So if anyone wants to follow along, please, you're welcome. So usually you need to install, of course, like Gradio, transformers, and a sentence piece for this particular demo. But after that, you can literally just copy paste this code, and you will be able to. Sorry, you need to put install. That makes more sense. And you will get a working demo in a couple of minutes. So maybe let me show you like a bit more like what's going on here. So we import Gradio, then transformers, and in transformers you can have like this pipeline function in which you just specify a task, which can be text classification, summarization, translation, image segmentation, and then you can even specify like which is the model that you want to use. So this model comes from the hub. This is from the Helsinki NLP group. So we can go here. They have a nice model card, and this is a model that translates from English to Spanish. It has a bit of data related to the metrics, the benchmark, and this group, the Helsinki NLP group, has done quite a bit of extremely interesting work. They have shared 1,300 models. I think most of them are just translation models, and these are like pair models, so from one language to another. And it's very interesting because here you can find like all kinds of matches of different languages. All right. So the first time you do this, of course, like it will need to download the model from the hub. So it will take a bit because the models can be from very small to a couple of gigabytes. But anyway, so here I have like this interactive demo directly in my Colab. I can click here like some of these examples. I can click submit, and it will run inference that is given out to me, which I can take a screenshot. It will be downloaded and I can share in Twitter if I want. Yeah, I don't want to like be like go too much in the details of this exact inference code because this is really dependent on the library that you're using, but it will work with any library that you want to use. Anything else that you see, such as the title or examples, are just like UI things. But as you can see, like it was very easy to create this demo. So, all right, so I built an ML demo, but then how do you share it, right? So you have like this Colab and you get this link, which is only available for 72 hours. But what if you want to share it with anyone else? And that's where Hugging Face Spaces comes in. So Hugging Face Spaces is like the third pillar of the hub. So we have models, we have datasets, and now we have spaces. So spaces pretty much allows you to host freely Streamlit, Gradio, or even like HTML demos that allows people to try out. So for example, these are like different models that are up there. So for example, there's like this deepfakes video detector demo, which you can try out with these examples. It will take some seconds. It depends. Like every demo is completely different. And for example, it's telling me this video is fake, right? So this enables people to freely go here and create demos. We launched this about 5 months ago. Now we have over 2,000 demos created by the community. Let me show you quickly some of my favorites. So for example, this is voice authentication with Way2Back from with LM, sorry, from Microsoft. So this is with audio files, and this voice authentication demo allows people to upload 2 different audio files of the same person or of different persons. And upon clicking submit, it will tell me if this is the same person speaking. In this case, it is. Or let me pick 2 from different people. It will tell you these are different speakers. So it won't pass the voice authentication with LM. Another is face mask detection. So this allows people to upload images, and it will tell you who is wearing the mask correctly, who is wearing a mask incorrectly, and who is not wearing any mask at all. This is with Streamlit. As you can see, like the interface looks a bit different, and you can like even just drag and drop files. It will take a couple of seconds. Right, maybe this demo is a bit slower. In the meantime, let me show you another one, which is called Echocardiogram. So it allows you to put any image, and it will do like transfer learning or a one-shot face stylization, depending on what style you're aiming for. So for example, this was JoJo. You can also do like Disney, yeah, art, Spider-Verse, like different kind of things. By the way, this was like the previous one I was showing you before. And this is Mona Lisa Disney style. There's one other I showed you, which is Glide, which is a model from OpenAI. And what is interesting is that these models were public already. For example, OpenAI made the Glide model public and open source, but there was no way, like no easy way for people to try it out directly. So by creating these demos, we're pretty much making it easier for people to come here, put any image or any text and try out models directly and really see like how these models are working. So this is the last model I was showing you. So you put a text, let me see if it worked. Yeah, so you put a text such as an oil painting of a corgi, and you will get this generated image. Yeah, and it's quite powerful, really. So for example, this is an ancient Greek syntax analyzer. So you input some text, and it will generate like some different analysis using spaCy pipeline. So it's also like a tool for linguists, for example. And yeah, it's like very open. So this is like echocardiogram segmentation, in which it shows you like which is the left ventricle in the echocardiogram images. So it can be actually there has been quite a bit of interest also like in the medical domain in how to use this kind of demos. But anyways, like going back to like the high picture of how what Spaces is a place like a hub in which you have thousands of community built ML demos, which can allow you to create your portfolio, for example, in which you can craft collaboratively, you can showcase your work. And if you want to have this integrated with GitHub, you can have like GitHub Actions workflows that allows you to very easily integrate and connect these pipelines. So all of these spaces, models, and datasets, all of them are Git-based repositories. So you get version control out of the box. They are optimized for ML workflows. So in machine learning, usually you have like very large files. What all of our workflows allow you is to work with these very large files. And it's very well integrated in the ML ecosystem. So many people in the open source ecosystem is using Hugging Face either through transformers or through the hub as a place in which they can share their models or their datasets or their demos. And we have like a very strong collaborative approach. So we don't compete that much, and we try to collaborate with anyone in the open source ecosystem to really provide value and impact, like positive impact in the domain. And one very interesting project we have been collaborating quite a bit in the last since May of last year is Big Science. If you don't know about Big Science, it's a large workshop, it's a large project that is a collaboration between hundreds of researchers from many universities and companies as well. And the goal here is to train a large language model, but a bit inspired in CERN. The idea here is to do a more rigorous scientific approach. So for example, we're asking like the ethical questions before starting to train this large model. We are gathering like different data sources. We're trying to understand like which would be like all of the implications of this large model, and trying to make sure that the data is as diverse as possible. And this project is really like community-led, and it has grown to be a project that involves many people, and we have like 8 different working groups in different specializations. So for example, one group is more focused like in the technical aspect of this super high scale model training, while other groups are more interested in how to govern all of the data used to train this model. Another project that was quite interesting was the collaborative over here is the research. Yeah, it's the collaborative training project. So it was a collaboration with Yandex. And what this project allows people to do, and I will share the link. Sorry, I will share the link as well in some. Is to enable people without computational resources to train language models. So here we had a community in India, different people without GPUs, and what we were able to do is to have like distributed model training, and we were able to achieve state of the art with this technique called deadlock. So it's distributed training. It's similar in some sense or in idea to federated learning, but here the goal was not privacy, but distributing computational resources across multiple peers. And it was quite interesting. So it involved 40 people, which were just opening Google Colabs. Yeah, so we have around 50 contributors. And these were people that were just opening Google Colab and signing and contributing a bit of their compute resources. But after all, like they were able to train this model, which was quite interesting. Because what this enables is to train powerful models for very low resource languages in communities in which you might not have that much data. And yeah, I think that was pretty much everything I wanted to talk to you about how to use the hub to share models, share demos, share datasets. If you want, I can